All right, let's dive right into this explainer and explore how the refining industry measures and manages extreme risks to prevent absolute disasters. We obviously hear a ton about the oil and gas industry in general, but today we're zeroing in on the downstream side, refining and marketing. This is where crude oil actually gets transformed into the fuels and products that power the modern world. But that transformation process, it is inherently dangerous, and managing that risk is a massive, highly structured undertaking.
Look at the sheer scale of the danger here. It's pretty staggering. We're not talking about leaving a mop bucket in the hallway. As this quote from the SASB industry standards highlights, refineries are handling highly reactive chemicals and volatile hydrocarbons, often under extreme heat and intense pressure. When you mix highly reactive materials with that kind of pressure, the margin for error essentially drops to zero. A single failure doesn't just mean a broken pump, it can literally mean a catastrophic explosion.
So here's how we're going to break this complex topic down into 5 logical steps. 1, the reality of refining. 2, loss of primary containment. 3, Tier 1 and Tier 2 events. 4, tracking the near misses. And finally, 5, building a safety culture.
Let's start with part 1, the reality of refining.
These immense physical dangers aren't just an internal headache for the engineers on site. They are meticulously tracked using precise accounting standards to ensure corporate accountability. The framework we're looking at comes directly from the SASB standards, which is now governed by the IFRS Foundation. This framework dictates exactly how refining companies have to disclose their sustainability and safety risks to investors. Why? Because, quite frankly, an unsafe refinery is an absolutely massive financial and operational risk. And here's the crucial point. When things go south, the fallout doesn't just politely stop at the facility's fence line. An accidental release of hydrocarbons doesn't just halt production, it triggers severe environmental contamination, and it poses a direct, immediate threat to neighboring communities. The social and environmental fallout from an uncontrolled release of highly reactive chemicals can devastate a whole region for decades. It's very much a shared risk between the corporation and the public. Which brings us to part 2, loss of primary containment. You've absolutely got to know this industry term LOPC, which stands for loss of primary containment. It's defined as an unplanned or uncontrolled release of any material from a process. And notice this detail right here. It includes non-toxic and non-flammable materials. I mean, even if it's just hot steam, compressed air, or nitrogen, if it escapes containment unexpectedly, boom, that's an LOPC. Because the escape of literally any material means you have officially lost control of your highly pressurized system. And that makes LOPC the absolute foundation of a process safety event, or PSE. Every single PSE is rooted in losing control of the materials being processed. It's the overarching metric the industry uses to track safety failures. If the product isn't exactly where it's supposed to be, you have an LOPC, and therefore you've got a process safety event. It's the ultimate baseline metric for danger. Moving on to part 3, Tier 1 and Tier 2. The standards divide these actual loss of containment events into 2 main buckets, based entirely on the damage they cause. Tier 1 represents an event of greater consequence, while Tier 2 represents an event of lesser consequence. Both mean something went terribly wrong, obviously, but the scale of the fallout is what separates them. Let's look at exactly how those thresholds are defined. Okay, so Tier 1 covers the absolute worst-case scenarios. On the human impact side, we're talking injuries severe enough that an employee actually loses days of work, or, tragically, a fatality. It also includes any event that puts a third party in the hospital. For the community, it's a Tier 1 event if local authorities have to declare an official evacuation or a shelter in place because toxic gases are out there. And financially, any fire or explosion causing over $100,000 in direct costs. These are your headline-making disasters. Compare that to the Tier 2 thresholds. These events are less severe. We're dealing with recordable injuries that don't necessarily result in lost time and lower monetary damages like fires or explosions causing over $2,500 in damage. But listen, here is the huge takeaway you need from this. Both Tier 1 and Tier 2 are what we call lagging indicators. They only get recorded after a failure has already occurred and the damage is done. So, that naturally begs the question, how do we prevent these releases before they happen? Because if we only measure Tier 1 and Tier 2 events, we're literally just counting our failures. To actually manage the risk, we have to look much deeper into the system. That takes us to Part 4, tracking the near misses. Enter Tier 3 indicators.
These are defined as challenges to safety systems. Basically, Tier 3 indicators are those crucial, hold-your-breath near misses where a disaster was narrowly avoided. There was no major leak, no one got hurt, but the system was pushed to its absolute breaking point, exposing a really dangerous flaw or weakness in the internal technical barriers.
Tracking these specific technical challenges tells a facility exactly where their safety barriers are failing before a catastrophic release happens. It's exactly like checking the brake pads on your car before you completely lose the ability to stop. Take an automatic safety shutdown, for instance. The system worked, which is great, but why did it have to activate at all? Or what if an inspection reveals a pipe is corroded right past its safe operating limit? Measuring these Tier 3 near misses gives operators the exact data they need to fix the weak links in the chain before they snap and become a Tier 1 tragedy.
And finally, Part 5, building a safety culture. This brings us to Tier 4 indicators, which measure operating discipline and management system performance. These are your leading, proactive measures. Unlike Tiers 1, 2, and 3, which measure events that already happened, Tier 4 measures the daily habits and management systems put in place to ensure those disasters never happen in the first place. And this reveals a really fundamental truth about this industry. Safety isn't just about steel and equipment. It's deeply, deeply tied to human competence, training, and operating discipline. Look at these focus areas. We're talking about the quality of operating procedures, checking the capabilities of your contractors, and ensuring rigorous workforce training. Honestly, it doesn't matter how robust a steel tank is if the person operating the valve isn't thoroughly trained on the technical competencies required to handle highly reactive chemical processes.
So how do you actually measure that? Well, here are 3 exact steps the standards suggest for quantifying how well a company is integrating this safety culture into its daily operations. Number 1, are process area hazard evaluations actually being done on schedule? Number 2, are managers following through on required safety actions, or is a large percentage of them past due? And 3, are workers completing process safety training where their skills are actively verified? By tracking these exact Tier 4 metrics, a refinery can literally measure the real-world strength of its safety culture.
Ultimately, all of these metrics and standards point to one indisputable fact. Engaging and empowering your employees and contractors to safeguard their own health prevents accidents. The ultimate goal of critical incident risk management is an empowered workforce that can effectively detect and respond to emergencies. When you're dealing with massive hydrocarbon releases and highly reactive chemicals, the people on the floor are your first and, frankly, your best line of defense. They have to be empowered to speak up, shut down a process if something looks sketchy, and take immediate action to protect themselves and their community.
And that is summarized perfectly right here in this quote from the SASB standards. Human safety and agency aren't just a nice-to-have for the workers. They are literally what gives a refining company its fundamental right to operate. A culture that engages and empowers employees helps mitigate massive financial costs and ensures productivity, sure. But way more importantly, without that culture, without the trust of the workers and the local community, a refinery will absolutely lose its social and regulatory license to operate.
So I want to leave you with this question to think about as we wrap up this explainer. Are we measuring to react to disasters, or are we measuring to empower our people to prevent them? Because true risk management doesn't start with counting the cost of an explosion on a spreadsheet. It starts with empowering the person turning the valve. When a company shifts its focus from lagging Tier 1 tragedies to leading Tier 4 human empowerment, well, that is when a refinery truly becomes safe. Thanks for exploring this topic with me, and I hope this gave you a whole new perspective on how extreme risks are managed behind the scenes.